Hello everyone, my name is Sofan Saifullah. I'm from Department of Informatics Universitas Pembangunan Nasional Veteran Yogyakarta, Indonesia, with my partner Professor Rafal Drzewski from Institute of Computer Science AGH University of Science and Technology, Poland. In 26th International Conference on Knowledge Space and Intelligent Information and Engineering System, we will to present our paper entitled Non-Destructive Age Fertility Detection in Incubation using SVM classifier based on GLCM parameters. In here we are talking about the poultry productivity in a livestock has been developed using several technology or various technology such as the detection of embryo or age fertility by image processing or computer vision. This detection uses a handling technology on incubator in hatching system to obtain the content of eggs in a week. In Indonesia, some process was done manually by human eye detection and they are not optimal. So we are focused on developing methods or concept for detecting chicken eggs fertility to get optimal result in detection. In here we are use the image processing and computer vision concept by GLCM and SVM methods to check to detect the chicken eggs fertility. This is the detection process from our research from the data set that we are using here based on the previous research, and then we use the image pre-processing and feature extraction, and the last is a detection. Image processing is used to obtain better quality image from the feature extraction. The method used include image acquisition, pre-processing, and segmentation, and the last is the result. The resulting image will be used to extract the feature using the GLCM methods by 6 parameters will use as an input for the SVM classifier used for chicken eggs fertility detection. Dataset and image processing method that we are used in here, we use 100 image. There are 50 fertile and 50 infertile, include a single object, an egg, and has a black background captured by handling process performed with a LED last flight and a smartphone camera located in a dark room. We can show in a figure, and the image acquisition process produce a digital image that will be further used after pre-processing during the detection phase. The accurate dataset include two type images. They are fertile and infertile of the age. Based on the previous result, we use the image to create a GLCM parameters. In here we are use 6 parameters: energy, contrast, entropy, variance, correlation, and homogeneity. The GLCM method, which is second order statistic based feature extraction. The GLCM is a metric that describes the occurrence frequency of the pixel pairs neighboring pixel relationship of a certain intensity located at the distance and direction from a grayscale image. And the next process we will use SVM classifier. SVM classifier algorithm is used for pattern recognition and classification using a machine learning. In here we are use supervised learning approach. This algorithm uses the principle of structure-wise minimization or SRM, which applies the linear classifier methods in linear and nonlinear case. Based on the classification by SVM classifier, we can use the confusion metric to analyze the performance of the given algorithm. The accuracy calculation are used to get the information what the percentage of the correct or true data from the all processes data is a valid data. So we are use the accuracy formula in here to create perform of our method. This is the experiment with the image preprocessing method used for GLCM feature extraction input preparation. The first we are use the cropping process from the image segmentations to get image black white and crop the original image. In here we are can see the figure A and B and C. The A is the process cropping, and the C is the process conversion from the image RGB or color image to grayscale. And the in under is a histogram of the each process by CLA, HA and CLHA. The histogram acquisitions with the contrast limit additive histogram acquisition and the combine of the two methods histogram acquisition. This is the GLCM and sample calculation that we are processed based on the image that we are know about. The image is imaging by image metric is used for GLCM calculation of SIG feature parameters or SIG parameters, and the calculations use the respective degree 0, 45, 90 and 135 degree. The calculation results are normalized to the range 0 to 1 and have 24 parameters. 4 values for each of the 6 GLCM parameters corresponding to 4 degrees values. Then the number of the parameters used is reduced to 6, each of which is a value of the given GLCM parameters average over then 4 degree values. This is the sample of the normalized values of 6 GLCM parameters, each for 4 degree values calculated for fertility image. So this is the result have 6 parameters and 4 degrees. The value of the result, they are have number 0 until 1. So we can see the table in here. And this is the sample of the each fertile and infertile. We use 5 data for each fertile and infertile. We can see the GLCM parameter of the fertile chicken egg and GLCM parameters of the infertile chicken eggs in here, based on the image that we are used to get the GLCM parameters. And this is our scenario of SVM GLCM method experience for egg fertility detections by the training data and the testing data, and we got an accuracy. From the two types of the eggs processed by SVM GLCM methods, fertile eggs has higher accuracy of detection than infertile ones, which has also confirmed by the previous research. This is because the acquired infertile eggs image have characteristics similar to fertile image eggs, and they will be classified. The result indicate that SVM GLCM has higher accuracy than the other approach from the previous work. The smallest difference is between the result obtained by the method proposed in this paper and BP GLCM approach is 5.2%. This is the comparison of the purpose method and the previous result that we mentioned in the previous states. In here we are going to compare by the backpropagation method classification, Cummins clustering, and SVM classifier. The difference from the others methods that our proposed method is SVM and GLCM, and got the accuracy more than 98%. Based on the SVM method of the fertility detection was able to increase the accuracy of the BP approach from the previous study from 93% to 98.2%. And yes, GLCM based parameter are also an essential factor for obtaining good result and improve the accuracy of the detections of the chicken egg fertility, as indicated by the comparison between the all of method that the previous research. The conclusions of our research: the experimental result show that our proposed method SVM GLCM can be detect the chicken egg fertility. The proposed approach use image processing method for improving the image quality and GLCM feature parameters as input from SVM classifier. Based on the previous research of Saifullah et al., the dataset is used in this study and the result was compared by obtained accuracy. The dataset was obtained from its scaling process, which was captured by a smartphone camera. The dataset was pre-processed to get a better quality image, and then it was used as input for GLCM based method for fine extract feature. The 6 GLCM feature parameters were used as input for detecting the fertility of chicken eggs using the SVM classifier. The present results of experience show that the SVM GLCM detection method obtained the average accuracy more than 88%. The proposed method obtained better accuracy of detection of the chicken egg fertility than the methods from previous study using the same dataset. For future research, it would be interesting possible direction to apply the agent-based versions of bio-inspired meta-heuristic algorithm as basis for adaptation and optimization mechanism development for machine learning method used for image processing and classification. The use of agent-based version of evolutionary algorithm seems particularly promising as they have proven themselves in multi-objective optimization, multimodal optimization, and decision support. Agent-based evolutionary approach was also successfully applied to neural network optimization, which might be particularly useful from the point of view of the edge image classification problem.